The reports of building materials, rock and stones. Rock, the portion of the earth crust having no definite shape and structure. Stone, the natural hard substance formed from mineral and earth materials which are present in rock. Geological classification. First, igneous. These are formed as a result of solidification of molten mass, magma, lying below or above the Earth's surface. Color depends upon the mm, amount of feldspar. Generally, magma consists of quartz, mica, and feldspar. The texture of rock is greatly influenced by the rate of cooling of magma. Mostly, these rocks are crystalline, glassy, and fused texture. Example: granite, sienite, deep rock, and plutonic. Deep rock, plutonic, and dolerite, basalt, rock surface, effusive volcanic. Second, sedimentary rock, also known as aqueous or stratified rock. These are formed due to the gradual deposition of materials like salt in water uh, and sand, clay, or fragments of magma, etc. The rock are soft and can be easily split up along the bedding as well. As normal plane. These rocks are soft and can be easily split into in the bedding, split along the bedding as well as normal plane. Example: dolomite, magnesite, gypsum, chemical deposits, limestone, shale, chalk, organic rocks, sandstone, fragmental rock. 3. Metamorphic rock. These are formed from igneous and sedimentary rock as a result of action of earth movement, temperature change, liquid pressure, etc. Igneous rock. Metamorphic rock. Igneous rock are granite, sienite. Its metamorphic form is gneiss, gneiss, dolorite, basalt are igneous forms and its respective metamorphic is schist. Sedimentary rocks, dolomite and limestone, its metamorphic form is marble. Sedimentary rock, sandstone changes to quartzite, shale changes to slate. Physical classification. Stratified rocks shows the layer along which the rocks can be split. Example: sandstone, limestone, shale, slate, marble, etc. That is almost all the sedimentary and sediment metamorphic rock. 2. Unstratified rock do not show any stratification and cannot be easily split into thin layers. Example: almost all the igneous rocks. Mm, Third is foliated rocks. They have the tendency to split up only in the definite direction. That is, almost all igneous metamorphic rocks are its example. The third category is chemical characteristic. Siliceous rocks. The principal constituents of siliceous SiO2, that is sand. These rocks are very hard and durable. Example: almost all igneous and igneous metamorphic rock. Gregarious rocks. The principal constituents are clay, Al2O3. These are hard and brittle. Example: salt, laterite, sandstone, etc. Third, calcareous rocks. The principal constituents is lime, CaO. These are good surface texture. Example: dolomite, limestone, marble, etc. Now, the stone, granite or cyan- cyanide, cyanide. Suitability: most suitable for important engineering works used in exterior facing of the building. uh, Fine grained granite offers high resistance to weathering characteristic. It can be easily polished and worked. Excess of feldspar causes early decay. Water absorption is less than 1%. Next, marble, most suitable for monuments, ornamental works, flooring and decorative work. Electric switch board also used in electric switch and boards. Specific gravity is 2.65, crushing strength 70 Newton per mm square. Marble. Next is basalt rocks, metals and concrete aggregates. High specific gravity of 2.6 to 3. Basalt. High crushing strength of 150 to 190 Newton per mm square. 5 is 4. Quartzite, railway blast road metal and Ca. Slate, used in cisterns, damp proofing. Second, excellent roof covering material. Specific gravity 2.89, crushing strength 77.2. Sixth, sandstone. These stones are used in roofing, flag shine and pairing. Second, grit, heavy works and no burn bural ornamental. Specific gravity lies between 2.65 to 2.95, 65 Newton per mm square. Crushing strength, quartz plus lime plus silica. This was all about sandstone. Now comes limestone, flooring, roofing and paving of walls. These are manufactured of lime concrete. Specific gravity 2 to 2.75, crushing strength 55 Newton per mm square. Affected by forest and frost and atmosphere. Limestone. Now comes Genesis or Guineas. It has a rough surface, rough stone work like street paving. Guineas, and its characteristic are quartz and feldspar, strong and durable. Laterite, very good road metal. Sand clay stone, sandy clay stone is laterite. Now comes concord. Foundation of building, irregular in shape, impure limestone. Morum, fancy path like garden walks, decomposed laterite. Now we move on to clay products. Bricks. Clay. Clay is the most important raw material used in making bricks. Purest clay consists mainly of kaolinite, 2SiO2, Al2O3, 2H2O, with a small quantity of minerals such as quartz, mica, feldspar, and calcite, magnesite. Bulk specific gravity of clay bricks ranges from 1.6 to 2.5. Classification of burnt bricks. Highest classification based on dimensional tolerance, compressive strength only. First class brick. Property of the brick are the perfect dimension for good brick. These bricks are table molded and they are well burnt in kinks. These are deep red, cherry and copper color, and the surface should be smooth and regular with parallel sharp and straight edges and square Corners. These should be free from flaws, cracks, and stones. First class brick. No impression should be left on the brick when the scratch is made with by finger or nail. A metallic ringing sound should come when two bricks are struck against each other. Weight of standard bricks is 3 kg. Weight absorption. Water absorption should be 12 to 15% of its dry weight when immersed in cold water for 24 hours. Crushing strength of the brick is not less than 10.5 Newton per mm square, recommended for on pointing purpose, flooring, reinforced brickwork, and exposed facework in masonry structure. Second comes the second class brick. These are the same have the same property as of first class, except that these bricks are ground molded and they are burnt in kinks. Small cracks and distortion are permitted. A little higher than water absorption, 16 to 20%. There we had 12 to 15%. Here it is 16 to 20% is allowed. Crushing strength of the brick is 7 Newton per mm square, recommended for all important mm, and unimportant hidden works. Now comes the third class brick. These bricks are ground molded, and they are burnt in clamps. Underburnt, soft and light colored, producing dull sound. Water absorption is about 25%, recommended for building temporary structures. Now comes the fourth class brick, overburnt, badly distorted in shape and size, and brittle in nature. Blast disintegrated of such brick is used for foundation, floors, lime, concrete, and road metals. Heavy duty burnt clay bricks. These are similar to burnt clay bricks and of same size but with high compressive strength. Class 400 compressive strength, not less than 40 Newton per mm square but less than 45 Newton per mm square. Class 450 compressive strength, greater than 45 Newton per mm square. Water absorption is less than 10%. Bulk density is 2.25 kg per mm cube. Composition of good brick earth. Important constituents: lime absorption 10%, functions: reduces the shrinkage on drying and preserve the form. If excess, over melt and loses its shape. Mm, Other causes may be changes red to yellow. Alumina 20 to 30% impart plasticity to the clay so that it can be molded. If in excess, produces crack in brick on drying. Silica 50 to 60% in brick. It enables the brick to retain its shape and imparts durability. Makes the brick brittle and weak in burning. Excess of alumina and silica causes brick shrinking during drying and wrapping during burning. These are the disadvantages of excess quantity of silica. Mm, The other functions of silica are prevents shrinkage and wrapping, whereas the disadvantage are if in excess may distort its shape. Next, magnesia less than 1% in brick except effect or help to impart color up to yellow. It leads to decay of brick. Iron oxide less than 7% gives red color on burning. Sufficient oxygen mm, gives dark brown if oxygen is not sufficient. Improves impermeability and durability. mm, Gives strength and hardness. If in excess, makes the brick color dark blue and or maybe black color. alkalis is less than 10% in brick. These are mainly in the form of soda and potash. Great value as fluxes, that is fusion. If in excess causes efflorescence, makes the clay unsuitable or for bricks. Important harmful substance in the brick earth. Lime present in lumps, absorption absorbs moisture, swells and causes disintegration of the brick. Iron pyrites (FeS2) tends to oxide and decompose the brick during the burning, may split into pieces and decolorize the brick. Pebbles, gravels will result in the weak and porous brick and spoil the brick appearance, may crack while working. Organic matter. Now, water absorption is increased and thus strength reduced. Manufacture of the brick, preparation of the brick, and shoaling. The top layer of the soil about 20 centimeter in depth is taken out and thrown away. Digging the clay is then dug out of the ground and it is spread on the level ground. Cleaning. It should be cleaned of stones, pebbles, vegetable matters, etc. Weathering. The clay is then exposed to the atmosphere, weather, and for at least 1 month to develop homogeneity and for softening of the clay mass. Bending. The clay is made loose, then add water and any ingredients to it. Tempering. Kneading the clay mass by fleet of men and cattle, done within 36 hours. Tempering is also done in plug mill called plugging. Yield about 1500 bricks. Now the second process is molding. The process of giving the required shape to the brick is molding from prepared brick earth. The first category is hand molding, preferred for soft mud. Next is ground molding, adopted when large level of land is available and do not have frog or lower surface too rough. Next is table molding, adopted when frog should be needed. After molding, the brick is carried to the drying site. The next is machine molding, preferred for stiff mud plastic method. Stiffer clay is focused Stiffer clay is forced into the rectangular opening. The come-out brick bar can be cut off by brick length. Brick bar is cut into brick length. Dry press method. Clay is fed into the mold of the mechanical operator. Press by applying high pressure. The mold takes the shape of the brick. Drying. The molded brick is kept in the sun to remove the moisture as to control the shrinkage and save fuel and time during burning. So drying is important. Most contents is brought down to about 3%. Most moisture content is brought down to about 3% and then exposed condition within 3 to 4 days. Under the exposed condition of 3 to 4 days, a gap is about 1 meter is left adjacent slake to allow free movement of workers. Now comes burning. The hydration period of at 400 to 600 degrees centigrade vaporizes in the remaining moisture. Oxidation period 650 to 900 degrees centigrade. Ferrous oxide is oxidized to ferric form. Vertification period 900 to 1200 degrees centigrade, melting and becomes strong up to cherry red. The burning may be done in a clamps yielding blast 60% of first class brick. Kinks yield about 90% of the first class brick. Testing of the brick. For the testing of the brick are taken randomly up 20 to 32 and 50 numbers from the stack of 2000 to 10,000, 10,000 to 35,000, and 35,000 to 50,000 respectively. Mm, If lot contains less than 2000 bricks, mm, the number of sampling shall be subjected to agreement between the purchaser and the supplier. The first test is water absorption, 24 hours immersion in cold water test. This brick have more water absorption capacity. It lose its strength earlier. This test is conducted in clean water at 27 plus minus 2 degree. 5 hours boiling water test. The immersed specimen should be boiled for 5 hours followed by cooling down to 27 to plus minus 2% by natural loss of heat within 16 to 90%. Water absorption in percent. Weight of water absorbed, weight of brick before test. Weight of water absorbed upon weight of brick before test into 100 is water absorption percent. Next comes the compressive strength test. Load applied at the rate of 14 Newton per mm square per minute till failure. Compressive strength test. Maximum load at failure upon the area of the bed face of the brick. Next, rappage test. Rappage, bend or twist out of the shape of the brick, is measured with the help of flat steel on or glass surface wedge shaped rappage. The greatest distance of the brick surface from the edge of straightness. Two types: concave rappage, convex rappage, is shown in the figure. Try to understand. Moving on. Efflorescence test. This test is performed to know the presence of alkali matter in the brick. The brick is kept in a 150 mm dish containing 25 mm depth of water till entire water is absorbed or evaporated. The water again filled by 25 mm. Efflorescence is classified as percentage of efflorescence area on drying brick. Is greater than moderate for brick class up to 12.5, not greater than slight for higher class. Classification: nil, no visible deposit; slight, less than 10%; moderate, 10 to 50%; heavy, greater than 50%; serious, heavy and powdered. Next, frog. The incident of 1 to 2 centimeter deep formed from the top called the frog. The size of the frog should be 10 to 10 by 4 by 1 centimeter is provided for 9 centimeter high brick, is not provided for 4 centimeter high brick and extruded bricks. The purpose of providing frog is to form a key for holding the mortar before the bond is strung. Types of brick: solid brick, frogs not exceeding 20% of the total volume of brick; small holes not less than 25%; perforated brick having small holes greater than 25%; hollow bricks, holes opened to ends; cellular bricks, holes closed at one end; fire clay or refractory bricks, the clay which can resist high temperatures 1700 to 1800 degrees centigrade without melting and become soft, is known as fire clay or refractory clay. Burning in a special kinks, Hoffman's kink, the refractory bricks are formed, manufactured. Now comes acid refractory bricks, also called silica bricks, 97% silica, 2% lime, used in lignation furnace. steel industry, coke oven, etc., having siliceous and acid slag, cannot be used in a rapid temperature change, that is cooling and reheating. Basic refractory bricks, also called magnesia bricks. Magnesia is greater than 85%, highly resistant to corrosion, used in lining furnace, having basic slag. Now comes the bond in the brickwork. It's important, very important, and frequently asked in the competitive examinations. So be attentive. English bond is stronger than Flemish bond for walls thicker than 1.5 brick. Stretcher bond only when wall thickness is half brick, example, that is 10 centimeter. Header bond, header bond used only when the wall thickness is 1 brick, that is 20 centimeter. English bond, some appearance of both faces when even multiples of half brick wall. Stretcher, 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 header, header, header is English bond. Stretchers on one face and headers on to next face when the odd multiples of half brick walls, also called half bricks wall, stretcher on one face and header on the other face. Okay, now moving to Flemish bond. The facing and backing having some appearance. Bats are needed for odd multiples of half brick walls and needed fire and needed for even multiples. Blast bats, brick of lesser thickness are bats. And in the Flemish bond we have header, stretcher alternate in each layer. English are distinguished whereas Flemish are alternate. Moving on. Now comes lime, CaO. Until the invention of the Portland cement, lime was used as the chief cemetery. Lime is not only found in nature, is not found in nature in the free state. Calcium carbonate, limestone, after calcination forms calcium oxide, quicklime, and carbon dioxide evaporates, moves out. Since calcination, heating to readiness in contact with air. So calcination, definition of calcination is clear. Moving on. Varieties of limestone. Limestone is called calcite, calcination. Magnesite is called dolomite limestone, containing half carbon calcium carbonate plus half magnesium carbonate is called dolomite. Conker lime is impure lime obtained by calcination of conkers dug out of underground and commonly used for making hydraulic lime. Shell lime, very pure lime obtained from the shells of the sea animals, costly, used for painting and important works, soil stabilization, etc. Definitions of quick or pure lime, CaO, or also known as caustic lime. The lime obtained after calcination of limestone, specific gravity is about 3 to 4. Fat or rich or white or pure lime. It has high calcium oxide, CaO, about 95%, manufactured by burning shells, marble, white chalk, pure limestone, etc. Sets and hardens by only the presence of carbon dioxide from atmosphere. Hydraulic lime, lime containing small quantities of impurities like alumina, clay, silica, sand, iron compound, magnesium carbonate, sulfates, etc. It has the property to set and harden under the water. Hydraulic hydrated lime or slaked lime. When the quick lime is finely crushed, then slaked lime with a minimum amount of water, it will form fine homogeneous powered is called hydrated lime. Next comes the milk lime, calcium hydroxide. Calcium oxide plus water gives the calcium hydroxide plus heat. When slaked lime is mixed with small amount of water, a thin solution of like paint is obtained is called the milk lime, lump lime, quick lime coming out of kinks. Slaking, the process of calcium oxide and water slaking calcium hydroxide, hydrated lime and heat. Classification of hydraulic lime according to percentage of clay impurity. Feebly hydraulic lime 5 to 10% of clay impurities, moderately hydraulic lime 10 to 20% clay impurities, eminently hydraulic lime 20 to 30% clay impurities, poor or lean lime greater than 30% of impurities. Application of lime suitable for ordinary construction works. Fat lime is used in plastering and pointing. Hydraulic lime for masonry. Do not do not suitable for it's not suitable for waterlogged areas and damp condition areas. Mortars. A paste prepared by adding required quantity of water to a mixture of building materials like cement or lime and fine aggregate like sand or surkhi. Mortar made with coarse sand is stronger than that made with a fine sand. Commonly used mortars: cement sand, cement lime sand, lime sand, lime surkhi 1:2, lime surkhi sand 1:1:1. Functions of fine aggregates. Sand increases the crushing strength of mortar and reduces shrinkage. For fat lime, helpful to penetration. Carbon dioxide for carbonation. Surkhi, also called calcination clay pozzolana, that is obtained by burning of clay. Its chief function is to impart strength and hydraulic properties of mortar. Grout, the cement mortar or of the fluid consistency used to fill the voids and joints in masonry and to repair the cracks is known as grout. Also used in to increase the burn bearing capacity of the soil by injection. Grouting, the application of mortar concrete under the great pressure through cement guns. Now table. Pointing cement 1, sand 1 or 1 to 3. Reinforced brickwork cement 1, sand 3. Foundation work 1, sand 3 to 4. Masonry 1:, sand 4 to 5. Plastering interior 1:4. Exterior 1:5, 6. Type of mortar cement 1:3. Permeable crushing strength 0.75 Newton per mm square. Cement 1:6, 0.45 Newton per mm square. Lime 1:3, 0.45 Newton per mm square. 1:3. Cement lime interior 1:1:9, 0.5 Newton per mm square, and 1:1:6, 0.5 Newton per mm square. Moving on. Wood and wood products. These are the important parts. Timber. Trees may be exogenous or endogenous. What are exogenous? Let's know. Mm, Grown outwards, mostly used for engineering purpose, are exogenous. Its classification are coniferous, softwood, deciduous, hardwood. Evergreen trees having pointed needle, cheer, deodar, squile, pine, fir, walnut, etc. Characteristic: long straight trunk, distant annual rings, deciduous, hardwood, broadly broadleaf trees, deciduous. Examples: teak, oak, sal, babul, etc. Heavier and broad trunk, indistinct annual rings except polar and bass tree. The next category of the trees are endogenous, grow inwards, having fibrous mass. Example: bamboo, cane, palm, etc. Microstructure: the cross-section layer is visible to naked eye. Microstructure: pith or medulla. Let's have a look. Now in the picture it's shown outer bark, inner bark, cambium layer, sap wood, heartwood, pitch, medulla, rings is the cross section of the exogenous tree which grows outwards, and its example were red a bit below, bit above. Moving on, pith or medulla. The innermost central portion varies from 10 to 15 mm in dia. Heartwood, the wood having inner annual rings. Associated portion of the trunk, it gives strong and firm support to the tree. Sapwood, the wood having outer annual rings, also called alburon, the active part of the tree containing living cells. Cambium layer, thin layer between sapwood and inner bark to grow wood cells on the outside and blast living cells on inside. Inner bark, the inner skin covering cambium layer. Outer bark, the outermost protective layer containing cells and wood fire, also called cortex. Medulla rings, the thin radical fibers extending from pitch to right angles of cambium layer. It holds together the annual ring and the heart and sap wood. Defects in timber. Pay attention. Important topic. Due to conversion, diagonal grain, torn grain, chip mark, vein. Due to fungi, blue strain, sap strain, brown rot, white rot, dry rot, wet rot, hurt rot. Due to abnormal growth or rupture of tissue due to the natural forces, heart shake, cup shake, star shake, ring gulls, linotes, upsets, foxiness, drunkiness. Defects due to seasoning, radial stake, twist, split, bow, cup, wrap, honeycombing. Seasoning of timber. Seasoning, the process of drying timber, that is removing moisture, sap present in fresh welded tree. Hygroscopic scopicity. Hygroscopicity of wood, the capacity of wood to absorb water vapor from air. Next, objects of seasoning. The purpose of seasoning are: reduces the shrinkage and wrapping after placement in structure, reduces its weight, reduces the split and decay of timber, increases the strength, durability and workability and resilience, makes it suitable for painting. Natural or air seasoning, about 4 to 6 months may require for natural seasoning. It reduces the moisture content of the wood to 12 to 15%. Artificial, rapid or clean seasoning, about 4 to 6 days may be required for clean up seasoning. It can reduce the moisture content of wood up to less than 10%. These were the objectives of seasoning timber. Moving on. Miscellaneous. Well seasoned timber may contain 10 to 20% moisture. For engineering purpose, strength of the timber is maximum in the direction parallel to the grains. Mostly asked. Strength of Tensile strength is 3 times the compressive strength parallel to grain. On application of external stress on timber, it behaves like elastic matter. Thickness of fiber board varies from 3 to 12 mm. Hope next is paints. Paints are non-transparent protective coating of fluid materials and they are applied over the surface of timber materials. Paints are classified as oil paints, water paints, bituminous paints, fireproof paints, etc. Ingredients, constituents of oil paint: base. It is a metallic oxide of fine powder, makes the paint durable on surface, imparts primary color. Coloring pigment may be added for final color. It reduces the shrinkage crack in film on drying. Base is the principal constituent, chief ingredient of the paint. Some of the examples of base are white lead. Lead becomes discolored when exposed to sulfur surface, most suitable for wood surface, not suitable for iron surface and delicate works. Red lead. Also acts as dryer when combined with linseed oil. Most suitable for iron surface is red lead. Zinc white, non-poisonous, less durable. It is difficult to work. Iron oxide, effective in imparting rusting and is cheap and durable. Generally used for priming coat and iron surface. Lithophone, the mixture of zinc oxide and bari barium sulfate. When exposed to daylight, it changes color, hence used for interior work only. Aluminum powder, it keeps the moisture content of wood surface and also prevents cracking. Generally used for priming coat and new woodwork. Titanium white, non-poisonous and provides a thin transparent film used for receiving and coat of an enamel. Vehicle carrier or binder. What are these? Let's know. It holds the constituents of paint in suspension and helps to spread it over the surface. Linseed oil, raw stand, pale boiled, boiled, double boiled, tongue oil, poppy oil, nut oil, etc. Solvent or thinner. It is added to make the application as workable, consistent, and easy, and that is easy and smooth. Turpentine oil spirit, most commonly used solvent. Naphtha, benzene, used as substituents, and petroleum. Colored pigments, added if color of the base is not desirable. Dried, dryer. What are these? Used to accelerate the process of drying, hence it is an admixture. A dryer absorbs oxygen from air and transferred to binder. The quantity of dryer is not greater than 8%. Litharge, lead acetate, red lead sulfate, magnesia dioxide, adulterant. It is another admixture used to increase the durability, keeps the pigment in suspension for long time. Advantages of it is roughness in development of the bond with next coat. Barium sulfate is most commonly used. Best adulterant, varnish. It is homogeneous mixture of resinous substance in solvent. Object of varnish: brighten and shine the appearance of the grain of wood, protect the painted surface from atmospheric action. Dryer may be used as per requirements. Solvents for resins. resin, amber, copal, solvent, boiled linseed oil, lac or shell lac, metal, methylated spirits of wine, gum, domer, mastic, rosin, turpentine oil, cheaper type of resins, wood naphtha, distemper, or what we call samosin. It is the mixture of white chalk base and water solvent. Mm, Objects of distemper applying on plastered surface to create a smooth surface, hence plastered surface are not exposed to weather. Facts: distempers are available in powder or paste form. They are mixed with hot water base before use. Distemper are cheaper than paints, coloring pigments. Distemper may be used as per requirements. Miscellaneous paints, enamel paints. These are the mixture of base and varnish. These are acid and waterproof, non-affected by the alkalis and gases, mainly used for woodworks. Aluminium paints. Mm, It is mixture of aluminium powder as base and varnish. Attractive appearance, visible even in the darkness, is aluminium paints. Fireproof on asbestos plants. The main constituents is fibrous asbestos used for stopping leakage, that is damp proof. Anti-corrosive paints. Dry red lead base with linseed oil, vehicle, cellulose or lacquer paints may be made by cellulose sheets on nitrotin nitroton dissolved in petroleum. Castor oil is also added to improve adhesion. The cellulose hardens by evaporation of the thinner, whereas the ordinary paint hardens by oxidation. The cellulose paint hardens by evaporation of the thinner, whereas the ordinary paint hardens by oxidation. These they resist the adverse weathering condition. Plastic paints, plastic base with water thinner. These are highly costly. 1 liter of plastic paint covers 15 meter square of wall surface per coat. Plastic paint. 7 is the putty. Lime on chalk base with raw linseed oil binder. These are cheap and used for exterior facing putty. Note for oil paints, varnishes, distemper, additive like coloring pigments, dryer are may be added as per the requirements. Hope you like the lecture, the course. Thank you.